Well, hi and welcome to my shop, and thanks so much for joining me here today. The next step I'm going to go with this receiver is to do the tube socket voltage check process on it, where with the radio operating you measure all the voltages on all of the tube socket pins compared to a chart of expected voltages, and maybe you can track down some more anomalous things. And also it basically verifies the operation of the radio to a large degree. Yesterday I ended the video playing the radio and somewhat disappointing result. Didn't pick up much, and I realized later in the evening that I didn't have the antenna switched on down here in my shop, so it didn't really have an antenna on it. So I think the first thing I'm going to do is play the radio. We're going to check it out quickly, just get comfortable with the fact that it's operating. I may even remember to look at the wattage consumption. I really want to know what the actual wattage consumption is on this radio. And then from there, I'll set up to start doing the voltage checks. It's basically completing this table of tests right here. Okay, I'm going to just leave the radio as it is right now. And let's see, switch it on here. Okay, plug it in. Don't think I can get my camera too much higher than this. Okay, we're just more or less checking its operation. It's plugged in the wall. Oh, but I have to turn on the wall plugs. Here we go. Let's try it again. Here we go. Bingo. Okay, so we'll let that warm up. A little bit of audio, and over here. Okay, that hum is the radio. Just turning up the levels here in my shop. Here it comes. Very loud. So probably what's happening here is I just have to adjust a few different volumes. There we go. That's probably a pretty high level coming out of the back of this set, heading into my audio system. So it doesn't take much to work. So there we are, in the band we're on right now. So we're at 14 megahertz. That's more like it. Now that's ham radio transmission, something called FT8 or FT4. That sick sound sounds like so many, I don't know, it sounds like dead people moaning in a cemetery. That could be 5 or 10 different ham radio operators simultaneously transmitting on the same frequency. It's pretty interesting stuff, but only if you can decode it. So we're just doing this quickly to make sure the radio is still operating. Let's go down around 10. Here's 10. I'm not likely. I'm trying to pick up WWD, but it's really not very likely. And let's go up to 11 shortwave stations. Okay, so the radio's working. So we don't think good. We can try the BFO on this. Yeah, it's definitely working. It may not be strong, or it may not be set quite right yet, but it's working. The last thing I want to do, I just want to take a quick trip down to the broadcast band here. It's 2 megahertz. Okay, we're in the broadcast band now. 1300. 1400, 1400. One more band down. So the bottom of the AM band coming up should pick up a few stations here. One of the things I loved about this radio when I first got it, because I was doing a lot of broadcast listening to distant AM broadcast stations. This is the only radio I've ever had. Maybe my call-ins would do this too, where you can be tuned to a broadcast station, listening to it, and on the way to the next station, the next frequency up, you can get to a dead spot in between. It just, you have two, not really strong, but okay stations to listen to, side by side, and you can tune between them. How this radio does that, I don't know, but it did. It does, so it's fantastic. But today there's so much noise on AM radio.
They say there is a possibility that these common adverse reactions may actually be aggravated by underlying diseases.
Should be a French station up here. There it is. I'm not hooked up to a directional antenna, just hooked up to basically a folded dipole is what this radio is connected to right now. Okay, that's good. Let's shut it off and turn the power. Oh, turn it back on. Turn it back on. I'm going to read that power consumption here. Hey, come on down. Check this out. Oh, you can't get down there. Okay, I'm going to read it on my own. Power. 143 watts. So 150 watts. And some of that is 4 light bulbs up here. Okay, so we'll shut it off. Pull this out. I guess we want it unplugged. Okay, so I'm going to get the radio ready for doing the voltage study here. So the voltage study is done with all tubes in, including the one you want to test. So that would imply having to work underneath the chassis. And it's a huge cord here. It's a big heavy cord too. It's going to pull itself off the bench all the time here. You know what I'm going to do? I'm going to prevent an accident here. What I'm doing, I'm just going to sort of freeze the cord here. So you could work underneath the chassis and carefully touch every terminal with your voltmeter. You can get through this work doing that, for sure. You could. But I have an alternate way of doing it here, which hopefully is going to work for all these tubes. And that's to use these tube extenders. Thank you, Mr. Viewer, for sending me these tube extenders, which I've used a few times, and they've been very helpful in very certain situations, and this is a big one. So all I got to do, let's say we want to do this tube. Out comes the tube. Did I say something about you didn't? Uh-oh, I see a problem already here. Let's pull the tube out. The set is not operating right now, but look at this. Well, isn't that a... So one of the key problems is measuring the tube voltages on these tubes right here, these ones in particular. The underside of the sockets are not exposed from underneath. It's contained in this can here. The only way to do it is with one of these. Now I see there's some screws here holding this collar on. I've never removed a collar like this, and you've got to wonder, is that a nut and screw arrangement? There's a nut underneath? I would hope not. But it could be a nut underneath, so if I loosen this from here, we'll never get it tight again. And these are important to be tight because this is supposed to be making good electrical contact with this to provide shielding. What am I going to do? Well, you know what I could do? I could stay away from those. Let's stay away from these. Stay away from these tubes for now. That's probably the best way. Concentrate on the ones I can do. Okay, so as a demonstration, this is the other end of the tube numbering. This is tube number 20 here. Take it out. You take the 6 pin, 7 pin. This is a 9 pin. Hey, wait a minute. Maybe, you know what? I had the wrong one. Maybe it's still got a collar on it too, so this is no easier. Hot diggity dog! It goes in. Oh, I had the wrong extender. Okay. Most video makers would erase, would delete all this, and they would not let you see this crazy mistake. But I'm going to let you see my stupid moves here. Let's try this now. Hot diggity dog. Of course, the people who made this must have reasoned out that it had to be the same, you know, or smaller width than a tube. So we put it in. You see how easy how easy this is? Hey, you know, first one. Here's one of the rules I followed in life. First time through can always be written off to education. And that couples with another principle that I've learned in life, and that is there's always a cost to education. What could it look like? Your dad's teaching you to ride a bicycle. While he's teaching you, what is he doing? He's not doing anything but teaching you. That's the cost right there. His time, his effort. You can't learn anything without there being a cost. So if you're self-teaching yourself, guess what the cost is? The cost is going to be your mistakes, your time reading a book and not really absorbing what's in it, a third time reading through the book and all that kind of stuff. There's always a cost to education, so plan for it. That's what I say. Okay, so we're on tube number 1 here. The next stage is for me to get a reliable voltmeter going. I'm going to use my indicating meter over yonder. Hey, what's this? Yeah, a dusty, dirty cat is showing up. Getting in your spot there? Here, let me just clear it up a little bit. Okay, there you go. What are you seeing out there? She's looking out the door. So here's my meter over here, which we will try to keep an eye on. Okay, all the tests are done relative to the chassis, so make a chassis connection there. This has to be set to DC. Woohoo! It was not on DC. Here's warmed up. Pretty high B plus on this radio, but I don't know what it is offhand, but we'll find out pretty quick. So, but the radio's still off, and I'm just kind of demonstrating how this is done. There are contact points here for each pin, and they're numbered. That's number 7. And you just put the voltmeter on like that, take our elbow out of the way and read the meter. Write it down on a piece of paper, move on. That's what I'm going to be doing. Well, Shadow, should we do the first one? Yeah, because maybe something more stupid is going to happen here, so we don't want to miss stupid. Okay, so I'll plug it in here. Again, we're going right into the outlet, so to speak. I'm not going through my power supply. I have not changed the fuse in my newfangled power supply gizmo. We have no audio hooked up. We should hook up some audio just in case. We're going to go on the outside once again, which is where the rather strong signal here. Didn't I figure out these had to be done a certain way? Is one of them marked? No. Well, we'll try it this way if there's a big hum. I mean, you know, when I'm doing the work, I won't be listening to this anyway. Okay, did I have the volumes up? No, I did not. Good show. Okay. Turn it up a bit here. Not a sound. Not a sound. Okay, you ready? Shadow, we're going to turn it on. She's on. Hear a little bit of a hum there. I think there's a hum right in the radio itself. The radio itself is humming. When I tested this tube, the 5U4, the heaters did not get red enough to even see. But there certainly are red here. A little bit of volume on the front panel, please. No antenna hooked up at the moment. Okay, so just verification that the radio's operating. So turn down the volume, and I'm going to turn off the sound on the video, so you're not listening at all to the radio anymore. You won't be listening to anything when I do this. I should keep listening to it, Jim, because I'm going to put them, because for interest's sake, when I touch those tube contacts, let's turn it back up. I turned up a little bit here. Oh my gosh. That's kind of interesting, eh? That's kind of interesting. So I had the volume way up on my panel over here, which is why the hum came through so loud. Okay, I think I'm in a position now to make more mistakes. Where's the okay. Oh, what happened there? I think the volume control is intermittent. Let me just... Okay, it could easily be anything in my sound system. Could have done this here. Shadow could have... Did you do something, Shadow? Were you poking with these? So clearly there's something that kind of comes and goes in this radio on the audio side. Seems like when I turn the volume up high, it breaks into operation. It's not like dirt in the volume control. Concentrate, Shadow. Concentrate. She's staring out the door of my shop. I think she's watching the peanut. Okay, now I got everything sorted out here. I think we're ready. I don't have the chart in front of me. That's the one thing that's missing. So we're just going to do tube 1. This is a remake of the original chart, of course, so it may have errors in it. It's got an asterisk there. And what does that mean? What does an asterisk mean? AC. I think these are all AC tests. Come on. Voltage chassis measurements made Western voltage indicated at. Those indicated by asterisk were made with the Measurements Corporation Model 62 VTVM. Okay. So these are very small voltages, maybe. I'm using a VTVM on the whole thing. Now what they're trying to warn here is the instrument they used affects the readings a little bit. So that's why they're describing, they're telling you exactly what it was. Weston Model 663 volt ohm meter. Puts a little load on the circuit that it's reading. The VTVM won't put really any load on it. Oh, I need this chart. So I think we're good to go. We know what we're doing, at least enough to think we know what we're doing. So now, shadow's not the star. The voltmeter is the star of the show now. Pin 1. Didn't hear a thing. Didn't see anything. So pin 1 should read. I think it says 1 volt there. 1 volt. So on the 1.5 volt scale, it's going slightly negative. Let's watch again. I mean, it's just barely moving. There's nothing there. So we want to quickly get a reading on this meter to verify it's working. So I'm just gonna jump ahead here. Pin 5 should have 200 volts on it. Pin 5. 1, 2, 3, 4. This is pin 5 here. Wow. Pin 6 should have 90 on it. Oh, you know what? That wasn't. Yeah, that's 5, 6, 7. Here's 7. Oh! Hey! There's a better way into this radio than through the antenna. Anybody want to say it? That's a little strange. So I left the radio tuned to the French station, didn't I? Yeah, it's French, all right. Just for interest's sake, that pin is a not measured pin. 8, 7. First measured pin is pin 6. So 7, pin 6. I'm getting nothing on the meter here. So either this tube isn't powered. That's just ridiculous. That's ridiculous. That's ridiculous. Let's just go around here. Something more. We see. That's a good reason why I left the video running, because look at all these weird things that are happening here. Okay, I'm just going to go right around and watch this meter. 7, 6, 5. Is my meter working? I don't think it's working. Oh, look at that. There is a reading. That's on 3. On 3, and we're getting a big voltage here. 250 volts on pin 3. What's going on here? What am I doing? Oh. Pin 3. 250 volts on pin 3? Do I seem to be paralyzed? RF gain maximum. It's not, but because I'm on ABC right now, maybe that's a problem. So I'm very terrible at setting the controls properly. You know, audio gain control at minimum. CW mod switch on CW. CW mod. Okay, so that's now on CW. You could hear the change in the sound. I can't imagine that's going to change this. Pin 3 is a heater. Pin 3. I must not have done 3 here. This can't be 3. Son of a gun. What is going on? Okay, so the heater has 250 volts on it. Pin 4 is grounded. Pin 5, 200 volts, nothing. Pin 6, 90 volts, nothing. Pin 7, not measured. Is there something going on with this test? Is this tube actually dead and that's why this does nothing? How can you possibly hear it like this, but not hear it like this? Well, how do you end up with a big voltage on the heater? And the tube. Oh, I can tell the tube's working here. Hot as can be. Ooh, hot as can be. It's because it's drawing 250 volts through the heater. Wow, I don't know. I'm just totally wacko here. You know what? Let's look at the schematic, because maybe you know there could be problems with these cables. And let's look at the schematic on the computer here, because the paper one is so hard to manage in the shop. Okay, there we are. And we're curious about tube number 1, way out here. And what we're curious about, pin number 1 is reading 250. Pin 5. Hey! Pin 5 has the plate on it. Wait a second. Where's that sheet again? Yeah, so pin 5 should have 200 volts. The plate. Pin 6 is the screen. Should have 90 volts. Jumping on pin 3, which isn't even numbered on the diagram, because it's this. It's actually this side right here. 7. Pin 7 is the heater pin. Usually it's 3 and 4. And for some reason they don't number the other. It's done very clearly. 7 to ground, but they don't number the other side. They always indicate which pin is grounded. Interesting. They've done this. Don't know why. Absolutely consistent though. So how can I possibly get this kind of reading? The answer is I don't know. How do you? Something is going terribly wrong here, somewhere in the deal. 1, 2. Oh. This might not be pin 3. Pin 3 may be spare, and they may be using pin 3. It says here pin 3 has 6.3 volts AC on it. The 3 and 4 are normally the, I have to get the tube diagram for 6BA6. Can you believe it? Let me just quickly get it in front of me here. 6BA6. 6BA6. So heaters are pins 3 and 4. Like the heater shorted to the plate. I tested these tubes. There's no shorts in them. Sure, goodness, if you get a heater short to the plate, you have to work your way through the grids in the cathode to make that happen. I don't know how that happens. I don't know. What's this going on here? The set's miswired when it's been working without the first tube properly all this time? That's nonsense. Boy, I had no expectation anything like this was going to turn up. Hey, radio, what happened to you just now? What's happening here? Okay, a shock test. Didn't seem to do anything. Okay, this is the volume up and down. Down. Yeah. So every time I raise the volume up high enough, the radio breaks back into operation. That's a characteristic of this radio that's been around for a while. Okay, back to the testing. Oh, smokes, man, I don't even make it through one tube today. Right, first time always written off to education. I'm paying the price, and you're paying the price too. Pin 1, nothing. Pin 2. Pin 2. That's the 150 volt scale, so that's 90 volts. Hey, that sounds familiar. Supposed to be on pin 6 though. Am I counting these pin numbers backwards? Oh, that's what I've been doing all the time. Yeah, you see, I spend most of my life underneath the chassis, counting clockwise or whatever it is, and now I'm above the chassis. The problem is the number 1 right here, you'd swear it's a 7. That's the problem. You can see that really clearly. It looks like a 7. That's my defense for having done this. See in the camera, 7. Well, there you are. There's the price paid for a tiny little bit of education. A big price paid for a tiny little bit of education. So here we've got exactly the 90 volts we're supposed to have. Pin 2, pin 6, pin 5. Oh yeah, pin 5. Like I did start thinking there's no voltages on this anywhere. So now we're on the 500 volt scale, 250 volts, and it's supposed to be 200. 200, but it's actually reading, yeah, 250. Okay. Now you've seen the process. I'm sure it's going to go smoother all the next tubes, especially with her help. That should work out. So I'll mark on here 90 and 250. Higher is kind of curious. That's all we really got to do on that tube. Although we could look for the -1 volt on the pin 1. Let's give it a go. -1 volt. So we'll switch this to minus. We're on 1.5 volts now to go full scale in the minus direction on pin 1. Pin 1 is not. Pin 1 is over here. Right over. So pin 1 measured with this. So I got distracted there. We're on the 5 volt scale. Looks like 1.5 volts. 1.7 volts. So this could be reflective of the fact that when I touch the probe, a signal starts coming through and it develops an ABC, and the ABC is reflected back, probably making it a little more negative. Shouldn't be any signal coming into the radio while you're doing this. It should short the antenna, really. That wouldn't kill it, would it? That wouldn't kill it. It's easy to short the antenna here. No. It could well be that the signal here goes through a tuned circuit and arrives here. Could be why it sounds weaker here. This is a better antenna. Oh, fun with radios. Oh, now the sound disappeared as I was reaching down and touching these cables a little bit. Like a momentary interruption here results in the sound dying out until I do that volume thing. Isn't that odd? Let's see if we can make it happen here. Nope. So why the sound disappears and then returns, I don't know. Is it because of this? Don't know. Okay, got one tube done. I'm going to spend the rest of my morning going through all the rest of the tubes, completing this chart, and then I'll be back on the video looking at the result, and from there that might lead us into some troubleshooting and stuff like that. So in the meantime, Shadow, who's now looking very Sphinx-like, is going to just hold the fort. She's going to keep me company while you're away. Well, you know what? I haven't gotten too much further forward here. I'm on tube 2. And I'm obviously still paying the price for learning. So I didn't notice there's actually 2 lines for each tube. So there's certain voltages that should be on tube 1. You make a change to the radio and you get different voltages. And the change is the RF gain control, which is really throwing me off. Now, I've always known there's something special about the RF gain control in this radio. And when you have it set to AVC, the control doesn't do anything. But when you have it set to not AVC, the RF gain control is doing a lot of things in this radio. And it looks like it's adjusting the B plus voltages on the lead tubes. Or is it? No, you know what? I don't think that's right. I think what it's doing is it's adjusting the bias manually. And it's never worked on this radio. That's right. That's right. That's what it is. You know, I don't think that's true either. Let me just do the test here. And get the meter in sight. Okay, so we're going to go on pin 1 of tube 2, which is the same deal as tube 1. They're both 6BA 6RF amplifiers. They pretty much run the same way. So there we are. So we should see RF gain control. No variation at all. So just make sure you... Oh, there we go. Okay, you know what? The ABC switch was set in the wrong place. Hey, more money paid, more price paid. Now we're cooking. Now we're cooking. So on this pin, I'm turning the RF gain. A lot of the stuff I said a couple of minutes ago was really stupid, so kind of erase that. We'll turn the RF gain and we'll watch this meter go. And it's supposed to go up to 54 volts, which would be, on this scale, full scale. It's right on the money. Okay, so yeah, everything I said before, ignore it. In fact, go back 3 or 4 videos and ignore all that too. So plate voltages now. Get to what we really want to do. Plate and screen voltage is really all we're testing for. The chart, please. And these voltages change with the setting of the RF gain, which is, I find, a little bit strange. I can understand the grid voltage going up and down, but so 210, 100, or 260, 240, depending upon how the RF gain is set. That's really surprising to me. I never realized this before, what it was doing. So we'll go on pin 5 and we'll look for this 210 to 260. Pin 5, 765. Come on. 765. I'm counting them the right way now. No, I'm not. I'm counting them backwards again. Oh my gosh. Just, you know, hey, force a habit. 5. That makes more sense. So 5 on the 500, so it's 250 volts on 5. 5 is supposed to have between 200 and 260. Okay, so I'm going to turn back on here. Okay, there we go. Going up. Okay, so here it's at on the 500 scale, it's 310. And the other extreme is 260. 260 to 310. 260 to 310. 260. No, you know what? This is a 260. 310. So it's running 50 volts high on that. Oh boy, this is going to take me more than all day to do this. It's like 15 minutes a tube here. 20 tubes, work it out. So we'll try this on the plate now. The plate should be going between 100 and 240. Or maybe that's actually the screen. So we're here, right where I can't see. Okay, we're no, Virginia County backwards again. Man alive. Paradigms run strong. Okay, so with the RF gain of one extreme, we're seeing on a 500 volt scale about 110 to 300. 110 to 300. 110 to 300. 110 to 300. So we'll look at these readings a little bit here. Tube 2, 2 tests, gain max, gain min. I'm getting, instead of 210 to 260, I'm getting 260 to 310. That's a 50 volts high. And this one, instead of getting 100 to 240, I'm getting 110 to 300. 300 is quite a bit higher than 240. You know, where would the problems lie? If this is a problem, where would it lie? Oh my gosh, who knows where? You'd probably find the same inconsistent voltage ratio throughout all the tubes. Like the whole screen voltage is high throughout the radio. That may not be the case at all. It may just be high for, maybe these tubes. Or, I don't know. Shouldn't think too hard until all the tests are done. A little like my cat. Look at her thinking away there. Yeah. Okay, I think I'm good enough now to carry on my own. Thanks for being with me to this point. I'm on my own from here. Well, I am almost done. I'm on the output tube now, so I thought I'd let you watch me do the output tube here. The radio's off. So yeah, I was talking about the cost of education, and that there's always a price to be paid. So I learned about this guy here. What I learned is, if you grab it this way, even though I was aware of this, it's very easy to make contact with one of those terminal contact points and get a really good shock. So the price I paid, the shock. The lesson, I turn the set off now when I'm changing the tubes. Yes, when I'm doing this. I got through quite a few of them before I got a shock. Okay, output tubes in. Back on. Oh my gosh, there's smoke coming out of something. Oh my gosh, quick. Power. I saw it. Hey, good thing I turned the camera on. So what happened there, because I saw it, oh, I hope nothing worse happened. The breath, oh, it smells burny in here, that's for sure. So the clip bracket that clips the tube in, this clipping part is contacting that test contact, and that thing was red hot when I came around. Just red hot. Hey. You know what? I almost missed a chance to get video of smoke coming out of my and you see what happened? I have it plugged in directly into an outlet rather than through my usual stuff. And so this is a classic safety thing. When you panic, you revert to your most basic, strongest understandings of things. Your older understandings, the things you believed when you were younger, all that kind of stuff, just comes into the fore right away. When I saw the smoke, the first thing I did was reach for my panel, but my panel's not doing anything. And at that point, you probably saw me stumble around in here for a moment while I figured out, what am I going to do? I was going to reach over and try to turn it off and decide that's not a good idea. Yank this out of the wall in the end. So, lots of lessons here, lessons for all of us, me included, of course. I happen to be the guinea pig. Now, okay, all the excitement's over. Let me clear the short on the back of this thing here. I mean, red hot. That thing got red. Maybe it welded. Huh? You know what it did? It melted off a piece of the contact strip back there and stuck it onto the tube clamp. So it did do some welding. Yeah, so one contact here is burned off. Most of it, half of it's burned off. Oh man. You never know, right? Like I can't see it, it's hidden from view, the problem, the whole thing. Hey, how do accidents happen? Something we should always pay attention to throughout our lives, every time we have an accident. Every time. Okay, ready for another accident now? So this guy wiggles a bit. He's virtually coming into contact there, so I'm going to stick a barrier in back here. You really can't see exactly what's up. I just need a piece of paper. Well, here's one. So the idea of the paper is to add more fuel to the fire. So when she goes up, it's more exciting than just smoke. Now, did this cause any damage to the radio? Well, it was pretty quick, so it probably didn't. It managed to heat this up, red hot. What else in this radio got heated up red hot during that moment? Oh, I hope I didn't do any real damage to it. It didn't pop the fuse. Didn't pop the fuse. By the way, what fuse is in here? Set's turned off? Yeah. Oh, this was a bad move. Hey, there's a fuse and a fuse. I didn't even know that. Yeah, maybe I should have checked this right off the bat, because occasionally, you know, back when I was much younger, I didn't have a whole bunch of fuses around, so whatever I had was going to do. Let's see what this is. This is a half amp. Can't imagine it getting much smaller than that. This is probably in the high voltage circuit or something of that sort. And what about this other one? Something funny about it here. This is a locking type, isn't it? Push in, yeah. I think so. No, Jim, just push it in better. Something clicked in there. The whole thing's moving around. We have to look underneath the radio to make sure we don't have some kind of mess. What's in here? A big melted fuse is what's in here. Holy smokes, I can't get it out. Okay. Plugs out. Let's tip them up on the side here. And we'll go after that. Up we go. Wow, it's a heavy beast. Hold on, we haven't got it right. What do you grab onto here? There. Okay, there we go. Still sitting on the cord here, but that's okay. Okay, fuses. Fuses up here. Up, 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 up. Two typical fuse holders in there. It's a chance to look at the power cord also. Now, I don't think I'm the guy who put this power cord on. So how have they done it? So the green wire is on the chassis. The white wire is going there. Power wire is heading into the big transformer. Can you see that? Those contacts you see in a bit of a circle formation, they actually go all the way around underneath this. Let's take a look like that. That's the bottom of the great big transformer, right? The great big toroidal transformer. Those are all the connections I had to make in there, so I'll let go. And all this wire, you dare not move this wire around. So it looks like I've taken one out of the bunch here and soldered it over here for reasons I can't remember anymore. Okay, fuses. So the top fuse I took out is connected to the power transformer, but it could be on the high voltage side of it. This one's clearly on the power coming in. Let's see if we can get it out. Because for some reason it won't come out. Why won't it come out? Something funny going on here. There we go. Got it. I got it. Okay, it looks like a slow blow style of fuse here. I don't think it's a big one. $250 volt, 3.15 amps. 3.15 amps. And what do you think it's supposed to be? I'm going to find out. I'm going to find out what it's supposed to be. Okay, it's supposed to be a 3 amp fuse, so 3.15 can't be a problem there. And I think that's a slow blow style of fuse. I'm not sure. That's a little awkward here. So the good news here is that the pin that shorted on here was pin 7. So just in thinking about that for a minute, pin 7, that's a heater pin. The power coming out of the transformer is causing a lot of things to get red hot. All the heaters and all these tubes are getting red hot. And that's no problem for that. That's supposed to happen. So I basically added one more heater briefly here on the other side of this tube. So I don't think it caused any problem at all. I don't think the radio even knows it happened. That's how subtle I think that really was. Okay, so we have the paper in. We are safe. We're ready to go again. We are plugged in or not. Oh, she's on. Whoops. Wasn't quite expecting that. Power consumption on this guy is 120, 126, 130 watts, 132, 34. I guess that's as the tube currents get going. No smoke, no fire. Let's just get going here again. Okay, I'm going to put the meter lead here. Get your eye on that meter. And the chart. This one's got quite a few tests to it. Now, this is V number, I can't be sure. So that's 19, 20. I can't be sure because that number's hidden there. 16, 18, 17. V17 we are on. Pin 1 and 2 not measured. Pin 3. So this is affected by the RF gain also. On purpose? Maybe not so much on purpose, but 260 to 280 on pin number 3. Pin number 3. Let me just, I can read the number right off there. 3. 3 is right at the front. 3, once again, we're looking for pin number 3, 200 and something volts. So let's put this over here to 500 volt scale. Pin 3. Okay, so 500 volt scale, we're reading 270, 275, and then I gotta turn the, thing control, it's way over here, it's way at the other corner of the radio. Okay, watch the meter. So it's going from 290 to 260, 260 to 290, 260 to 290. Should be 260 to 280. Doesn't sound bad at all. Next one is pin number 4, 228. Why they're specifying it down to a volt. 220, not saying 225 or 230. 228. Really? That's crazy. And that's on pin number 4. Okay, pin number 4. And the reading on the meter is 500 scale, 300 volts. And then we change our gain control. Oop, that's not the gain control. There it is. So it goes down to 270. Whoops, a little too far. 270 to just over 300. 270 to just over 300. Often these readings I've been taking have been about 10% high in almost every case. So probably the power supply itself is running high, and it could be because of this tube. Maybe. This isn't the proper rectifier tube, although apparently it shouldn't make any difference. Last reading is pin 8 on this tube. It gives us 12 and 13 volts. 12 and 13 volts. Pin 8. Oh boy. It was pin 7 that I blew up. Wow, pin 8's right on in the realm of a short also. Pin 8. Nothing. I got nothing on there. So that wasn't pin 8. Quickly, get the light on this situation here for crying out. 4, 5, 6, 7. That's definitely 8. It's only supposed to be 12 volts, so I bet you I had this up so high we couldn't see it. 15 volt scale. Pin 8. So it's just going off scale there a little bit, so it's like 17 volts or so. And it's supposed to be 12 and 13. Let's look at the variation when I do this. Get my hand in place. There we go. Okay. Nothing on fire. Okay, so that's a what scale am I? I'm on the 50 volt scale, so that's 13 to 16. 13 to 16. 13 to 16. It's supposed to be 12 to 13. You know, how important are these voltages to be exactly correct? V19 is a rectifier. I think I'm going to stay away from that. V20. I can't remember what it was now. What it's for. It's a small tube. It's not very hot. I was thinking, can you pull a tube out of the radio while the radio is operating? And could that ever cause a radio, something to catch fire or something like that? I think the answer is no, because everybody would design their radios so if a tube fails and isn't essentially not there, the radio doesn't catch fire right away. Well, I mean, that would be pretty sad, wouldn't it? You should be able to pull any tube out without any bad consequences. So this is where I get a shock. You see, my finger on top of this thing. I don't want to get a shock here. And this is how I get a burn. It burned and shocked. I'll tell my wife about it at lunch. Oh, 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 I just did get a burn. I touched this super hot guy here. He is hot. Okay, so this exciting tube now, V20, whose purpose I can't recall, but it's not too important. Let's give them a test here. So 96 volts on pin 2. 96 volts on pin 2. Oh, clobbering my microphone there with my head. I'm gonna do something useful with my head. Pin 2. I think it's this one. No, that's not pin 2. I think it's this one. Yeah, I really should read the numbers on here. Okay, now I know for sure. Pin 2. What negative? Whoa, whoa, where do you get that from? Negative million volts there. How's that happen? So this tube's supposed to have minus, it's minus. On pin 2, minus almost 100 volts. 96, and the actual reading there is just over 100. Ooh, I wasn't really expecting that. Minus 100. 105. And the same voltage should appear again on pin 7. Well, it sounds like the heater, doesn't it? 2 and 7. 2 and 7. Oop. That is 7, isn't it? No, 7 would be the last one. That one. Having trouble counting. Okay, same thing. And with no variation on the RF gain, I'm not even going to check. That is it. I have gone through all these tubes now, except for 1 or 2 that I'm not completely interested in. One of them, for instance, is tube number 3, because I don't even have it in. This is about driving the crystal. Crystal-driven oscillator, local oscillator, and I don't use that feature at all. So we're done. We're done. What do we get? Let's go over this right now, and I'm going to go eat some lunch. Hey, it's only 11:30. I got that done pretty quick. Here we are. Circled a couple. 125 volts, getting almost double that. Same thing here, almost double. So that's way out. Something going on there. Same thing down here, almost double what it's supposed to be. This is the most important one on this tube. I got a 0. Don't know how that's possible. This is the 1287 audio tube. Perhaps the tube is half audio, half something else, and the something else is not working. But there's only one plate. Isn't there 2 plates in there? You have to look at how the tube's constructed. I think that's a 2-part tube, isn't it? So something about that anyway. The rest of them, the voltages are just generally high everywhere, almost high everywhere. So I'm suspecting the, you know what tube I haven't tested yet? The one I really should test? And that's the OA2 voltage regulator tube. Would it be the case that if it's glowing, it's working? Would that be the case? Can you see a glow in there? I don't think this tube gets hot, does it? Oh yeah, it's hot. It's hot. It's supposed to get hot. Well, it is glowing. Let's turn some lights up here. My thinking is, if it's glowing, it's got to be working. It's the voltage is kind of a chemistry sort of thing, or a physics sort of thing. I don't know how it could be wrong. And that's why I'm going to test it, because I don't know. So this one, you certainly would not pull this tube out and operate the set with the tube out, because it's clamping a voltage at 150 volts. And if you unclamp it, where's it going to go? I don't know. Oh, that's hot. Come on. Oh, well, this radio really hangs on to its tubes. Where'd my tube extender go? Oh, it's still in the other tube. Okay, give me a moment here. Give me 1 second. Okay, the measurements are on pins 1 and 5. I'm going to turn the lights off, and we'll see it come to life. Here we go. Turn the right knob, Jim. There we go. Oink. Kind of interesting. Did a little flash lower down there, didn't it, for a moment? Okay, well that's the excitement. Hope you enjoyed it. The excitement of the startup. Now I need to make a voltage measurement here. See, I mentioned lunch, and now my head is all into what am I going to eat for lunch, all that kind of stuff. And the 2 pins, pin 1, pin uno, pin 1. Oh, we're looking for 150. My meter's set to 150. Hey, I got this one still up on an extender. I got 3 tubes on extenders here. 1, 2, 3. Okay. 2. Wait, what's 2, wasn't it? No, it's 1. 150. Oops. Let's try that again. You can calibrate your meter with this. That's right up on the, it's a 150 scale, it's right on 150. I think you could calibrate a meter with this. And 150 on pin number 5. 150. Okay. Very, very good indeed. Now let's turn the set off. So again, what is worth going after? Oops. So I'm going to study up on especially this guy here. How can the set work with this at a 0? Oh, that's a little better, right? How can the set work? The plate voltage on the 1287 is 0. I don't think the set can work. I don't think you can hear audio coming out of it. So, but I've done enough for now. I will do these investigations, and tomorrow we will see if there's something that needs to be done, or if there to deal with any of the anomalies other than the one I just pointed out. Thanks a lot for watching.